started talking about critical values, and I did it too early, but a critical value is something you're going to use throughout statistics. In this case, this is your critical value. This is called alpha. This is a Greek letter. We use a lot of Greek letters, obviously, in statistics. This is like a little fish-looking thing. It's called alpha. And this notation, if I see this notation, automatically, you should know that it is asking for a z-score with an area of alpha automatically in the right tail. Okay? Automatically in the right tail. Now, alpha could be a number, and typically in the right tail, usually they're small numbers, because critical values are usually, deep in the tail. So let me show you what I mean. Now we can go and do this. Find this. That's all you're asked. Find this, blah, z of, so alpha in this case is 0.1, right? Find z of 0.1. This is a subscript, and this is a z-score. Automatically, it's a z-score. So automatically, based on the fact that I want this, I know that I'm looking for a z-score. I know I'm on a standard normal distribution curve. I know the mean is 0 and the standard deviation is 1. This is a small area to the right, so it's all the way here in the right tail. I'll do my area in yellow. I am given that this area to the right of whatever this value is 0.10. I want to find this z-score that corresponds to that area, which is represented by this notation. I want to find z of 0.10. Find a z-score. I'm given area, inverse norm. Find a z-score from a known area, inverse norm, right? When I want a z-score and I know an area, inverse norm. When I want an area and I know a z-score, normal CDF. Be careful. Inverse norm, right? So second bars down to inverse norm. Again, remember, I'm going just with area to the left. Now, do I know the area to the left? I know the area to the right is 0.1. So what is the area to the left? It's 1 minus 0.1. So let's input 1 minus 0.1 here. Okay, 1 minus. Because I'm always inputting here area to the left, right? Not everybody has this part. So we're going to go always with the left. Enter. 1.28. 1.28. So this critical value, this z-score that has an area of 0.1 to the right of it is what I say, 1.28 approximate. Oops. 1 minus 0.1 is approximately 1.28. Let me check that. Let me double check that. I think that's what it said. Yep, 1.28. We round z-scores to the nearest hundredth. Okay, finding critical values. Typically, you're always going to do inverse norm of 1 minus whatever this thing is to find the critical value.